Okay, this is the Unit 2 review. So all this is just factoring. So if you need a review of all the different types of factoring, take a look at the 2.5 video. That is a brief overview of everything. However, on this review, I'm assuming that you know the different types of factors and, in essence, how to do them. Again, if you need a further explanation, here are the different videos that you should be looking at. For GCF and simple ABC, those are 2.1. Excuse me, yeah, 2.1 video. For grouping, with a little bit of squares, that is 2.2. Complex ABC, that is 2.3. So difference of squares and cubes, that is 2.4. And then a brief overview is on 2.5, and as well, obviously, right here with the review. So if you need a better explanation of these things, 2.5 is a good review. So 2.5 is an overview. So that one's a good one to look at to make some decisions. However, the deeper understanding is found in those individual videos. So here we go. I'm going to move a little bit quickly. And again, if you get crazy confused, you can go ahead and ask questions in class. But here we go. So here I see weird things, like some weird letters and different combinations of variables. So this is most likely a GCF. So 8 and a 4, I can take out a 4. An x and an x, I can take out an x. A y and a y squared, I can take out one y. So if I do that, the 8 turns into a 2, the x goes away, y goes away. The 4 turns into a 1, so I could write down a 1 if I want to. X goes away, and y squared turns into a singular y. So this would be 4xy with a 2 plus y. Okay, next. This is most likely a grouping, but first and foremost, I absolutely need you. I see that all of these numbers are even, so I can take out at least a 2 out of all of these things. But yeah, a 2 is the best I can get. So if I take out a 2, this is going to be a 15, a 5, 18, and a 6. All right, that's as good as it gets. Now this is grouping. All right, so if I group up the first 2, and group up the last 2, what I can take out is I can take out a 5 and an x squared. So that leaves a 3x and a 1. And here I can take out a 6, which leaves a 3x and a 1. Then outside 2. And so the remaining is the same thing. That's good. So this is a 5x squared with a 6. And the leftover stuff is the 3x plus 1. Which goes down to a singular multiple. Right here, I cannot take anything out, so this is going to be a complex ABC with the multiples of 2 and 2, which is a 4. So multiply to a positive 4, which is 1, 4, 2, 2. Because it's a positive, they're both positive or both negative. I need to add to a positive 5, so there's my positive 5 right there. Write it as a fraction twice, so that's 2x with a positive 1, 2x with a positive 4. Simplify if possible, so this is a 1x with a positive 2, so 2x positive 1, 1x positive 2, is your result. Okay, I know this looks a little bit different than what you're used to, but think of this as being an x squared x normal number. This is a simple ABC. This is a simple ABC. So the multiplication number is a 36. So let's go to that. So 36, 1, 36, 2, 18, 3, 12, 4, 9, 6, 6. Let's go ahead and write that twice. Because it's a positive 36, they're both positive or both negative. Going to a negative 13. Going to a negative 13 is this negative 4, negative 9. Okay. Now, if this were a regular x squared x normal number, this answer would be x minus 4, x minus 9. Because what happens when you have an x squared is this x squared breaks to an x and an x evenly. Cool, 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 cool. Well, same with this x to the fourth. It breaks evenly. So an x to the fourth is going to break to an x squared and an x squared evenly. So this is a simple ABC, but this x to the fourth breaks to x squareds. Okay, so this is going to be an x squared minus 4 and an x squared minus 9. Now, with this, heads up, I have a difference of squares right here. They're both perfect squares with a minus in the middle. So this first one, this x squared minus 4, you square root, which are x and 2. So nice, write it twice. One's plus, one's minus. Same with this x squared minus 9. You square root, which are x and 3. One's plus, one's minus. So that is your final result right there. Here I can GCF out a 10. So it leaves an x third minus 1. Now this is perfect cubes. So the perfect cube, square out, which is x squared and 1. Multiply to the middle, 1 times x is 1x. And then so, same, opposite, always positive. Outside 10, along for the ride. Okay, GCF out an x squared. So that leaves an x to the fourth minus 4. Again, I know you're not used to seeing it this way, but this is a perfect square. This is a perfect square. Square root of x to the fourth is x to the 2. Square root of 4 is 2. So nice, write it twice. One's plus, one's minus. Outside x squared, that's what you get. GCF out of 6. So it leaves x squared, 11x, and 10. So this is simple ABC multiplied to a positive 10. Positive means both positive or both negative, adding to a positive 11. Okay, this is most likely grouping. No, there is no common numbers right now, so this is most likely just straight up grouping. So I group up the first two, plus group up the second two. Okay, I GCF out of those individually. So this I can take out a 2x squared, which leaves a 6x minus 1, plus 1. Here I have to take out a negative, and I can take out a 5, which leaves a positive 6x and a positive 1. Notice how the insides are the same. That's good news. So the outside stuff go together, inside stuff goes together. That's what it is. All right, these don't have much in common, but what they do have in common is an n. So that n goes away, and I can take away one n of this. And so now these are perfect cubes. If you don't know what the cubes are, use your calculator. So 343. So for instance, this is going to be the third root. So you use that n root button. You make the outside, and 343, I believe, is 7. 64 is 4. Again, you can take the third root. 64 is 4. So these are perfect cubes. So this is 7m, 4n. Okay, so 7m and 4n. What I do is I square out. So the first number is going to be 49m squared. The last number is at 4n, so that's going to be 16n squared. And multiply to the middle. So 7m times 4n. 7 times 4 is 28. M times n is mn. Okay, then it's a plus, so it's the same. Opposite, always positive. Don't forget that there was an outside n along to the right. Okay, here again, you can do it two different ways. One way you can do is you can switch the order in which this thing comes. So you can look at it as 125 minus 64x to the third, or you can take out a -1 to begin with. So -1 comes out, and that's 64x to the third minus 125. It's all good. Regardless, these are perfect cubes. Doing it the blue way. Cube root of 125 is 5. Cube root of 64 is 4. X to the third is x. Square out. 5 squared is 25. 4 squared is, 4x is 16x squared. Multiply to the middle. 5 times 4 is 20x. Same opposite, always positive. So minus, plus, always positive. Same opposite, always positive. So that's one way that you can do it. Okay. One way you can do it, or you can do it this red way, and so it'll be similar, but just make sure you have an outside -1. So 64 is 4, x to the third is x, 125 is 5. Okay, square out, so 16x squared and 25. Multiply to the middle, 4x times 5 is 20x. Same opposite, always positive, so minus is a minus. Opposite is a plus, and the last one is always positive. And then there's an outside -1 attached to that. Here I notice all of the numbers are even, so I can at least take out a 2. So that's a 5x squared, 24x minus 5. This is a complex ABC with the multiplication being 5 times negative 5. So 5 times negative 5 is negative 25. That's my multiplication number. So 1.555. Multiplying to a negative means one of the numbers is negative or the other number is negative. Adding to a positive 24 would be the negative 1 and the positive 25. Write it as a fraction twice. So the first number is a 5x with a negative 1 and a 25. And so those are your results. So the fraction itself comes out to be a 5x minus 1 and a 1x positive 5. And then there's this outside 2 just along for the ride. Here I can factor out a 4. So that leaves an x squared, 13, and a 30. So this is now a simple ABC. So this is now a simple ABC with the multiplication number being 30. Okay, because it's positive or both negative. Adding to a positive 13. And when it's a simple ABC, those are just straight up your results. Positive 3, positive 10. Outside 4, along for the ride. This is grouping, no common numbers. So this is just straight up grouping. So I group up the 8x to the third with the negative 64x squared. And x with negative 8. So out of this first one, I'm able to take an 8x squared, which leaves an x minus 8. Here, I can't take out anything, but I must. So when you must, you can take out a 1. You have to take something, so you take out a 1. Now, that doesn't change anything, but that's okay. So now the outside stuff is an 8x squared and a positive 1, which is A-okay. And then we have an x minus 8. Okay, with so many letters, I'm assuming that this is just straight up going to be a GCF. So 20 and 5, I can take a 5. A and A, I can take out 1A. B to the 3, B to the 2, I can take out 2 B's. C to the 4 and C to the 2, I can take out 2 C's. D and nothing, I can't take out any D. So here we go. 20 turns into a 4, A goes away, B to the third turns into a singular B, C to the 4 turns into a C to the 2, and D remains. Okay, the second one. 5 goes away, or AKA turns into a 1. A goes away, B squared goes away, C squared goes away. Okay, here again, this is going to break to an x squared. Okay, this is going to break to an x squared, but this is a simple ABC. This is a simple ABC. That's how it starts anyways. So multiplication, positive 40. So that's going to be 140, 220, 410, 5, 8. Because it's a positive 40, they're both positive, both negative. Adding to a negative 13, negative 13 right there. Okay, this does break to an x squared. So this is going to be x squared minus 5 and x squared minus 8. Neither of those are perfect squares, so they are what they are. And that is the last question.